So we're going to be looking at 6.2. And what they want us to do here is complete this by factoring. One of the things that I want you to notice here is that the leading coefficient in front of this x squared is 1. So whenever it's 1, what we could do is make a table. And the last term, our c, is going to go right there. And our middle term, our b, is just going to go right there. So what we're going to do is find what we can multiply to get a positive 8. We have a couple of choices. 1 times 8 gives us 8. Negative 1 times negative 8 gives us a positive 8. We also have 2 times 4 and negative 2 times 4. The whole idea is to see which one of these we can add to get 6. Here we see 2 plus 4 gives us 6, which means this is the one we're going to be using. So it's really nice now, because what we could do is put our x in the front of both of these, and here we have a positive 2, so that's going to be a plus 2. Here we have a positive 4, so it's going to be a positive 4. So what we just did there was factored out that problem. And we can always check our work by foiling. So if we FOIL, we do x times x, that's x squared. X times 4 is plus 4x. 2 times x is plus 2x. And 2 times 4 is plus 8. We combine like terms, we get 6x. And we just bring everything else down. That x squared comes down, and that plus 8 comes down. And we see that this problem matches up with this problem. Therefore, our solution is correct. So, once again, we could do that again. Anytime our leading coefficient of our squared variable is 1, we can do that again. So, we're going to make our table. The 2 is going to go right here, and the 3 is going to go on this side. We want to find what gives us 2. Well, 1 times 2 gives us 2, and also negative 1 times negative 2. But we want to add one of these pairs to get 3. Well, here we see 1 plus 2 gives us 3. So we can go ahead and factor now. Because this is v squared, we know this has to be v, and that has to be v. And this is a positive 1, so we put positive 1. That's a positive 2, so we just put a positive 2 there. And we just solve this answer. And once again, remember, you can always check your answer by foiling. Let's go to the next problem. So here with this next problem, we make our table again. And the only reason we can make this table right now is because this is a 1. Our leading coefficient of our squared is a 1. So here we have a positive 88. So that's going to go in the first column. And then we have our b in the middle, that 3, which is going to go over here. So now we need to find the factors of 88. Or the numbers we can multiply to give us 88. So we know 1 times 88. Negative 1 times 88. We got 2 times 44. Negative 2 times negative 44. And will 3 divide into it? No, not. What about 4? So we have 4 times 22, negative 4 times 22. We also have 8 times 11. And we also have negative 8 times negative 11. And we notice here it doesn't matter which one of these we try to sum, we'll never get a 3. 1 plus 88 is not 3, for example. Negative 2 plus negative 44 is not 3. 8 plus 11 is not 3. Negative 8 plus negative 11 is not 3. And we'll notice that for all the other ones as well. Therefore, we're going to see that this problem is not factorable. So, let's look at this problem, number 10 on your homework. It wants us to factor the trinomial. Once again, we see that our leading coefficient is a 1. I also want you to notice that this has a variable and that has a variable, which means when we factor, we're going to have an s for the beginning because it's s squared, and since this last one's j squared, we're also going to have a j. Okay, and because our leading coefficient is 1, we could go ahead and make our table again. Negative 21 will go right here, and then it's positive 4 will go right there. So we just look for what factors of negative 21 give us 4. One of the options is negative 1 times 21. Another one is 1 times negative 21. We also have 3 times negative 7 and negative 3 times 7. Well, here we see this last one, if we do negative 3 plus 7, you see how this 3 is a negative, it's still a negative. This 7 is positive, it's still positive. Excuse me, that gives me a solution of 4. So that means in one of these I'm going to put a minus 3. And then on the next one I'll put a plus 7. So we got our answer. And remember, once again, we could check by foiling. So let's look at another one. Kind of the same thing like the previous one. Our first term has a variable and it's squared. Our last term has a variable and it's squared. And the nice thing is that we see that our first term has a coefficient of 1. So once again, we can set up our table. And we'll put negative 18 first, negative 7 next. And because of the way that it's set up, we know that the first one in each parentheses is going to be a b, and the last one will be an x. We just have to find the numbers. Let's find what we can multiply to get negative 18. We have 1 times negative 18. We have negative 1 times 18. We have 2 times negative 9. And we also have negative 2 times 9. And here we see if we do 2 plus negative 9, we get negative 7. So that's what we're going to put in here. That 2 is a positive, and this 9 is a negative. And we have our answer. And once again, remember, you could check by foiling. So here we're seeing a problem with this. Our leading coefficient is not a 1. So as of now, we cannot use that table. But one of the things we learned in the last section is that sometimes there's a GCF. But we see that all of these numbers are divisible by a 2. So we're going to pull that 2 out, and we divide. 2 divided by 2 is just 1. So we don't have to show it, we have t squared. Negative 24 divided by 2 is negative 12t. And a positive 64 divided by 2 is a positive 32. Well, now this is nice because we see that this leading coefficient is 1. So now we'll be able to do what we've been doing with the previous problems. We know a t is going to go there, a t is going to go there, and let's make sure we bring down that 2. So now we're going to look we can make our table with that part. We know we have a 32, and our middle term is negative 12. So after doing some work, you will see that negative 8 times negative 4 gives us 32. And if we add both of these two, we get negative 12. Which means in here, we'll put a negative 8. Right there, we'll put a negative 4. Now once again, make sure to check bifoiling. So another problem similar to the last one. Our leading coefficient is not a 1. Also, we also notice that our exponents are a little bigger. So what we want to do is find our GCF. We'll see, we want to make sure our leading coefficient is a positive one. So to make it a positive one, we'd have to divide by negative 2. So we'll divide all of them by negative 2. And also we'll see that they all have definitely an x4 in common. So we could divide by an x4. So this negative 2x4 goes in the front. We divide here, we get x to the second. Because the 2's will cancel, negative 2's will cancel, you do 6 minus 4 is x squared. But we have a negative divided by a negative is a positive, and it's a 3. 6 divided by 2 is 3. And here we do the quotient rule, 5 minus 4, we just get x. This last term, we have a positive 20 divided by negative 2, it's just negative 10. And we see that our x's cancel. Now we see that the leading coefficient in front of our squared variable is 1. So we will be able to go ahead and just do this problem as we have been doing the other ones. Because this is an x, we can put an x there now. And now from here we'll go ahead and start working. Make our table. We have a negative 10 and we have 3. And we see if we multiply negative 5 times 2, that gives us negative 10. But if we sum those, we don't get 3. But if we do 5 times negative 2, we see we'll get a 3 by summing those numbers. 5 plus negative 2 is 3, which means my 5 is positive and my 2 is negative. And we could check bifoiling. And the last problem we're going to do is factoring this completely. Once again, we see that we can pull some things out. These are all divisible by, well, they all have an m. And how many m's? 3 m's, 2 m's, 1 m. So it's going to just be 1 m. And they all also have an n. But how many n's do they all have in common? It looks like just 1. So that means that's going to come out in front. And now we divide. We'll see these n's cancel. And we do 3 minus 1 gives us m squared. Here we're going to have a minus 7. And then this is going to reduce to 2 minus 1 is just the m. Again, we look at the n's. 2 minus 1 is just n. And the last term we see m's cancel and we're left with the positive 10. This 3 minus 1 is just n squared. So we've seen something like this before where we see that that's squared and that's squared. And the nice thing is that our leading coefficient is 1. So we can just set this up the same way. We'll put an m first for this first m squared. We'll put an n last for this n squared at the end. And now all we got to do is make our table. We got 10, and we want to get negative 7. So we see that negative 5 times negative 2 gives us negative 10. And we see that if we sum those, we get negative 7. So we just put negative 5 here and negative 2 there. And our work here is complete. So that is 6.2.